Okay, now let's look at how to graph a very basic parabola. So currently we are learning about a parabola that the parent function is ax squared. So the a value controls the vertical stretch or the vertical shrink, and it also controls if the parabola opens up or down. So if a is positive, meaning greater than 0, then it will open up, which will mean just in general, it will look somewhat like this. So the vertex will be down here. So therefore, the vertex will be at the lowest point, meaning it will be a minimum. Now, if a is less than 0, if a is a negative number, it will open down. So in general, it will look something like this. And so the vertex will be a maximum. So in this case, g of x equals 2x squared. Our a value is 2. Therefore, we know it's going to open up. Now, we also know that if the 2 controls the vertical stretch or the vertical shrink, then since the number is greater than 1, it is a vertical stretch by a factor of 2. So when it says compare the graph to the graph of f of x equals x squared, this is a vertical stretch by a factor of 2. So let's get down to how do we go ahead and make our graph. So what I'm going to do is I'm going to have you make a table. Now in this case, I know that our vertex is going to start at 0. I'm going to explain how I know in just a minute. But if I plug in 0, 2 times 0 squared is 0. Now I'm also going to do 1 and 2 and negative 1 and negative 2. On a parabola, I like to have at least 5 points to graph. I want to have the vertex and 2 points to the left and 2 points to the right. So if I plug in negative 2 into my calculator, meaning I'm plugging in negative 2 where x is, I get 8. And if I plug in negative 1 into my calculator, then I get 2. So let's go ahead and graph these points. Here's the vertex at 0, 0. Here is at negative 1, 2. And here is negative 2, 8. So when it's a parabola, I know that it is symmetric. I know that there is an axis of symmetry going right down the vertex right here. So what that means is this point will also have a point right here. Notice that this point is 1 to the left of the axis of symmetry. And so it has a kind of a buddy point, 1 to the right of the axis of symmetry. So look up here at 8. This point is 2 to the left of the axis of symmetry. So it will have a little buddy point 2 to the right. Or if you plug in 1 to the equation in your calculator, you'll get 2. If you plug in 2, you'll get 8. So we draw on our parabola. Now, I am not the best at drawing these on a computer. So let's just see how I do right here. Yeah, it needs a kind of curve. We don't want it to be really a V shape. We want it to have like a more gentle curve. Like I said, drawing these with my mouse is not my best skill ever. So that is very roughly our parabola. Okay, we are going to try one more example, very similar, same steps, just to make sure we've got this. All right, our second example, we're going to work through the exact same process. So if you notice, the a value is negative 1/3. So the a value is less than 0, it's negative. So that tells me that my parabola is going to open down. Now I also know it's going to be a bit wider because if the a value is negative 1/3, the negative, what it does is it makes it open down. That means it makes it reflect over the x-axis, just like what we learned in previous chapters. Now the 1/3 by itself, the 1/3 makes it be a vertical shrink by a factor of 1/3. Now we don't put negative 1/3, we just put 1/3. The negative was already taken care of when we worked on reflecting. Now what we just did, that was the piece, that was the compare the graph to the graph of f of x equals x squared. So now let's go ahead and graph the function. So the function is g of x equals negative 1/3 x squared. So I know right now, because I only have just a number in front of my x squared, I still know that the vertex for now is going to be at 0. So if I plug in 0, then the vertex is at 0, 0. I also know that it's going to open down. So let's try some points to plug in. Now I'm going to go ahead and I'm going to plug in 1 and 3 and see what happens. So what I mean by that is in my calculator, I'm going to type in negative 1/3 times 1 squared. That's how I'm going to plug in 1 and 3. Okay, so if I plug in 1, I get negative 1/3. And if I plug in 3, I get negative 3. Let's go ahead and try plugging in something else. I'm also going to go ahead and I'm going to plug in 6. The reason I'm choosing to plug in 6 is because ultimately the number is going to be divided by 3. So if I plug in a number that is a multiple of 3, then my chances of getting a whole number to graph are more likely. So I get 1, negative 1/3. That's going to be about right there. And then 3 is at negative 3. And if I wanted to, I know that 6 is at negative 12, so I would have it right there. Now, to get the other numbers, I could fill out my table, or I could go ahead and I know that if this is the vertex, then the axis of symmetry is right here. So if this point is 1 to the right, then it needs to have a symmetrical point 1 to the left. If this point is 3 to the right, then at the same level, it needs to have a point 3 to the left. And same thing, this point is 6 to the right of the axis of symmetry, so it needs to have a symmetrical point 6 to the left. And then we're going to draw our curve, which like I said, is not my best thing on a computer. But there is my parabola. So it is opening down, and it's a bit wider than the normal just parabola of just x squared. Let me go ahead and draw on here the basic parabola of y equals x squared, just so you can see it. So the parent function of y equals x squared would just be starting at 0, 0. And then when you plug in 1, you get 1. When you plug in 2, you get 4. And 3, you get 9. So it would look like this. And then it would have the symmetrical points over here, or I could make a table to find them. So if you see, that is the parent function of the parabola. So you can see the reflection over the x-axis. That's what makes it open down. That's the negative. And then you can see that this is significantly wider. What I mean by that is if you graphed this after it reflected, it would look like this. So do you see how the parabola is definitely wider than it was? And that is where you see the vertical shrink. Remember, a vertical shrink is like when you take Play-Doh or silly putty or slime, and if you shrink it vertically, that means you squeeze it coming in from the bottom and the top. It's going to squeeze out to the sides, meaning it's going to get flatter, but it's going to get wider.